intersect at the same point. Name those line. Name a line. I don't need to know all three. Just one of them right here. All right, start us off, Cormac. All right, good start. If I draw in all three perpendicular bisectors, yes, they will intersect at the same point. And name that point that they all intersect at now. Here we go. Hearing from different people. Jared, where do they all intersect? Good job. Circumcenter. It's word association. That's how I tackle this. Word association. You say circumcenter, I say perpendicular bisector. You tell me perpendicular bisector, I'll tell you circumcenter. Next thing, should I know about that circumcenter? If I show you where it is on the triangle, you'll know what about it. What's the theorem about the circumcenter I should know? Ooh, on fire there, Cormac, what I'm hearing from other people. Shara? They are not congruent. What's that? What about them? You're just throwing words out. I need to put all this together here. Circumcenter is equidistant, or the same distance from what? From the vertices. Equidistant from the vertices. So if I show you where it is on the triangle, you can draw a line to all three vertices and they'll be the same length. Perpendicular bisectors, yes, they all intersect at the same point, and so do another set of lines. Give me another set here, Alyssa. Altitudes, there you go, working what we did yesterday. Let me stop right there. That is true, but that is also a vocabulary term in itself. So if I draw a triangle, describe to me what an altitude is, please. Describe to me what an altitude is. Going around. Vinny, describe what an altitude is.
It's from the vertice.
That's huge. Got it from a vertice.
It's perpendicular to the line across.
Good. So what should I see on here too if it's perpendicular?
Boxes.
Right angles. Yep. So there's an altitude. I draw all three in. They intersect at a point called the, from yesterday. 1, 3. Jonathan, they intersect at the orthocenter. There is no special fact about the orthocenter, but you should know where it's located based on the type of triangle I give you. So if I give you, hey, I have an acute triangle, we know automatically that the orthocenter is inside. If I give you an obtuse triangle, somewhere it'll be located outside that triangle. And if I give you a right triangle, know where it's going to be, definitely on, and you know exactly where it's going to be on. It's where the two legs meet, where the right angle is formed. Good job so far. And then there's one more set of lines that will all intersect at the same point, and that's called, they are called the, what do you got, Tess?
Angle bisector.
There we go. Angle bisectors. You draw all three of those in. They'll all intersect at the same point. That point they intersect at. Alyssa, going back to you.
The in-center.
In-center. Good work. We should know something about the in-center. If I tell you this point is the in-center, this is what you guys did for homework yesterday. What do you know about the in-center? It is 1, 5. Alexi.
The in-center is it's where all the lines are, angles are congruent.
Well, I know that's angle bisectors, yep. But yesterday on homework, we had point P was the in-center. So we knew something about PD, PB, and PF. Why? That's the fact I'm trying to draw out of you. Why were these congruent? Because of the theorem I'm looking for right now, that the in-center is equidistant from the what? The sides. There it is. And I know this is not going to be good news for some of you. I got a fourth one today to finally end all this. Okay, I got a fourth one today. All right, so this is where we're at right now. Okay, that's where we're at. And again, it's word association. You say angle bisectors, somebody says in center, equidistant from the sides. And that's where we are. All right, last night's assignment. Let's go. Where do we want to, anything we want to talk about here? Let's do this. Let's go, Makai. What do you got? 23? 24, yep. Okay. I know this is broken record, but this is the best way I can get through to it. EC is an altitude. EC is an altitude. What do I know about altitudes? What's coming to mind with altitudes? 1-4, Stephanie, what's an altitude? What's that? Okay, and there's a lot of things that come, angle bisectors come from vertices too, but different than an altitude. What should I know about an altitude? It does come from a vertice. The more important part is what happens on the other side of it. Perpendicular, so that means it forms a what? All right, now you're throwing out words again. You guys are throwing out words on me. You said it was perpendicular, and I'm asking you, what does perpendicular mean? It forms a what? 90-degree angle. So if EC is an altitude, it forms a 90-degree angle. Angles 1 and 2 add up to 90. We all would agree there. Angles 1 and 2 add up to 90. So I take angle 1, 2x plus 7. I add it to angle 2, 3x plus 13. Because an altitude forms right angles, that's what allows me to set it equal to 90. All right, nothing tells me they're congruent. Nothing tells me they add up to 180. It tells me it's an altitude, and I know altitudes form right angles, and right angles add to 90. So I am going to solve for x, plug it back into angle 1 and 2, and there we go. Other questions? More? Anything else? Tess, go.
Number
34. Okay, JM is an altitude. Here we go. I don't mind asking it again. Shar, what's an altitude again? Okay, see, this is something we just went over. I just asked Stephanie about it. Okay, altitudes. Where do they start? And what happens to them when they're drawn? What's that? A right angle. So tell me in my diagram where I should put a right angle symbol. JM. Yep. And? Okay. So those are right angles because I know it's an altitude. Boom! Automatic on your diagram. Okay. Right angle, right angle. You hear the word altitude, right angle, right angle. Now, JMP is 3x minus 6. 3x minus 6 JMP. So what can I set it equal to now? What's already there at JMP that I can set it equal to? What's already there, Jonathan? 90-degree angle, so I can set it equal to 90. Other questions? Anything else we want to look at? Yep, Vinny?
28.
28. DE, yep, good call. All right, so just before I do 28, you needed to do 27. Without 27, you can't do 28. Because 27, take a look, 27, you found the length of PD, which was 7.1. Because that's the in-center, special fact about the in-center. Here you go, everyone ready? Special fact about the in-center. Gonna keep doing it until I feel comfortable. Special fact about the in-center, Simon. In-center is always
Equal distance from all sides.
from the sides. So if PB is 7.1, so is PD. That's got to be 7.1. I already knew that PE was 14.9. Everybody take a look. Maybe you're not. Maybe you won't take a look. There we go. Everyone see my right triangle? Okay, going back to you guys. 1, 3. Jonathan, how many sides do I already know of this right triangle? 2 sides, and I'm trying to find the third. We've talked the last couple days. If you have 2 sides and you're trying to find the third, what can I break out here and use? Simon, back to you. If you know 2 sides of a right triangle, and I'm trying to find Pythagorean theorem. A and B are the sides that make up the right angle, which in our problem is 7.1 in the missing side. C is the hypotenuse across from the right angle. That's 14.9. And now I go to work. And make sure you take the square root at the end. If you want, you can plug this into NumWorks, into your equation solver, and it'll give you two answers, a positive and a negative. And we never want a negative side, so we take the positive. We good, Vinny? Good talk. All right. Anything else? All right, let me see it. We got to go back to work. Tuesday after break is the quiz. To say I'm nervous is an understatement. Yes, I know. I'm asking for a fourth time. What is an altitude? I know it has nothing to do with what we're doing in today's notes, but it leads into the first vocabulary term. So again, what is an altitude of a triangle? In your own words. Drew, all right, here we go.
Starts at a vertice.
Yep.
A right angle at the point across from it.
There you go. Have I ever said it does any bisecting? No, it does not. So that's why you've never seen hash marks for an altitude. Here's our next term. Median in a triangle. Median. Now take a look. Median still comes from a vertice, like an altitude. The only difference, it's drawn to the midpoint of the opposite side. It is not perpendicular. It is drawn to the midpoint of the opposite side. So what I'd like you to do right now, my diagram is missing some markings. All right, now that you know what a median is, that it starts at a vertice and goes to the midpoint of the opposite side, can you please put your own markings on? If AD is a midpoint, what do you know now? If AD is a midpoint, put some markings on my diagram, please. AD is a median, D is a midpoint. What is true now? All right, what markings did you put on your diagram now? So I can write it in my conclusion. Alyssa, what'd you put on there? Good job. And that's my conclusion. BD congruent to DC. Good work. Medians go to midpoints. Everybody, that's the saying I'm always going to have. Medians go to midpoints. Oh boy, here we go. Let's play a little game in your group right now. I have 4 diagrams here. 4 diagrams. You are going to look at the markings on the diagrams, and I want to know what's the best name for line segment CD. Here are your 3 choices. 4 choices. The 4 we've talked about. Is it a perpendicular bisector? Is it an angle bisector? Is it an altitude? Or is it our new one here today, median? Do not think all 4 are going to be used. Okay, you choose the best one. All right, so just because you get to D and you're like, oh, I haven't used this one yet, doesn't mean it's squat. Okay, you pick the best name for it. Not all 4 may be used. All right, so go in your group. Please talk to each other, Talk to each other. What is the best name for CD in each diagram? Go ahead. Just based on the markings, what's the best name for CD in each of those diagrams?
Yeah.
Where's your hash marks? No, you're putting those on. I didn't put them on. Whoa. You can't add your own stuff. You got to go just based on what I've given you there, right? Did I give you any hash marks? So where's the bisector come into play?
Oh, no.
Right? I got to give you perpendicular bisector means right angle and cuts it into two congruent parts, and I didn't give you the congruent parts. So I don't know if that's the best name for that.
So if it's still perpendicular, it would be an altitude, right?
It's the best name based on the markings I gave you. Again, can't be bisector because there's no hash marks. Here we go. Diagram A, your best name for diagram A. Ooh, Lily, go ahead. That is an altitude, right? Starts at vertice C, perpendicular to the opposite side. Now, hey, I do this. Now it's a perpendicular bisector, but I did not have that on there. All right, and we can't add that on there. All right, how about diagram B? What's CD? Best name for CD, Jared? That's a median. D is a midpoint. C is drawn to it, so that's a median. How about diagram C? Ones. Makai, what do you got? That is an angle bisector. Good. And how about CD? Hopefully you heard my warning and didn't just go, oh, I haven't used this one yet, so I'll throw that one down. CD. Best name for CD there, Dylan. That's, look, hey guys, comes from C, perpendicular down to D. That's an altitude. Questions? All right, rest of the class, let's start, let me go back and focus on this median here. So go ahead, do your thing, plot triangle ABC, and we'll talk. All right, so here's what you're going to do in your group. Find the midpoint of each side. We just finished the cumulative quiz where you needed the midpoint formula. Find the midpoint of each side and draw in the median from the opposite vertice with a colored pencil. All right, so your three medians should all be in different colors now when you end up drawing them. Real quick, can we just look at side BC? I don't think you need the midpoint formula for that. Right, I think you could just find the midpoint, count the distance, cut it in half, graph the midpoint, and then draw in the median from A. The other two sides probably you'll need the midpoint formula, but that BC, I don't think so. All right, go ahead. Use your midpoint formula, find the midpoint of each side, and then draw the median in with a colored pencil and straight edge from the opposite vertex.
Okay.
So it should have three medians, all in different colors, and you should notice something about those three medians. Kind of been the theme of this unit so far. All right, we got to move here. We got to move on. What do you guys notice? Kind of been the theme, right? What do you notice about all three medians? What's up, Lily? They all intersect at the same point again, right? Just like, oh, let me go back to my good old chart here from the beginning. My chart from the beginning, right? Perpendicular bisectors, altitudes, and angle bisectors all intersected at the same point. Well, now what am I going to add to it? So do the medians now, right? The medians intersect at the same point. And they all intersect at a point. Let me introduce that to you. It's already on your paper. Anybody want to let that roll off your tongue? Centroid. Yes, good. That is where all three medians intersect. Okay, so circumcenter, incenter, orthocenter, and now the centroid. And there is a fact that goes along with it, just like circumcenter and incenter has a fact that goes along with it. The centroid, let me write it down and you write it down and I'll show you how it works on the graph. The centroid, that point, the centroid splits any median into a ratio of 2 to 1. Okay. It'll take any median and split it into a ratio of 2 to 1. Take a fourth colored pencil if you have it in your group, a fourth one. Put a point where the centroid is on the graph we just completed. Put a point where the centroid is for me. And I'll show you how this works here, this new fact. Well, I want you to look at the median coming from A to BC. Everyone see the median I'm talking about, from A to BC, the horizontal one. How long is it from vertex A to the centroid? Quickly count, you don't need any formula. How long is it from vertex A to the centroid? How many units? 1, 2, 3, 4 units, right? All right, how long is it from the centroid to the midpoint of BC? 2. Everyone see what I'm talking about? This piece will always be double the length of this one. All right, so the segment from the vertex to the centroid is always double the piece from the centroid to the midpoint. Always, always. That's what this fact means, 2 to 1. All right, so everyone see, because now we're going to start putting numbers to these problems. All right, so you look at this problem below it. In the directions, it says M's the centroid. I'm like, all right, so that means median. So it's, again, word association. Centroid, medians, and 2 to 1. So now I'm going to give you WM is 16. What's the length of WX, the entire median? Well, I can't answer that unless you tell me what MX is, right? So I can add it to 16. So based on this 2 to 1 fact, what's MX have to be then? This is just the basic application of it here. Henry? MX only.
8.
8. Again, this piece is double the other, so that's 8. And now I don't have to ask anybody. Add them together, WX, 24. And then YM is 12. I'm looking for YO and MO. All right, well, why don't I start with MO? Because I need that to get to YO. So what do you think here? MO? MO? Shara, MO? 24. All right, that again, how are the question students always ask, how do you know which one's the bigger of the two? It's always the one from the vertex to the centroid. That's always the bigger one. So that's 24, and now everyone's got YO is 36. Good, good. All right, let's do a little algebra now with it. So you go to the last problem here. BG 2x plus 10, GE 3x minus 1. All right, what am I going to do with them? Right? What am I going to do with them? Let me write the incorrect response, which is taking them and setting them equal. They are not equal to each other, right? It's not a 1-to-1 ratio, it's a 2-to-1. So I'm going to ask one of you guys to adjust it for me. Adjust it so I can solve it correctly, because you are not solving this. This is an incorrect equation. They are not the same length. All right, adjust it for me now so I can solve it. How do you want to adjust it? 2-zip. Brendan, how do you want to adjust this?
You multiply the 3x minus 1 by 2.
Yep, I can do this. Or, and if you didn't want to do that, over here on the 2x plus 10, multiply it by 1/2, right? Because this is equal to twice the other piece. All right, now you can solve it. And make sure we're finding the length of BE at the end, BE. And when you're ready, what'd you find? I know X is 3, but I had to use X to get to BE. When you're ready, test when you're ready. Let me know what do you got for BE?
24.
Yep, you got it, 24. Take 3, plug it in. You should get 8 and 16. All right, I know that's the end of the notes, but I do want to do the first problem here on homework tonight, and that's filling out my chart, which is basically a study guide. It takes everything we've learned and puts it into one chart. I will help you out here because I am not concerned that you can do this or not, that you can write down a definition of each. So you can just X out that first column that says description. This is an English class. What impresses me more is that you can draw a picture of each of those. So I'll do the perpendicular bisector row, and then I'll let you finish the rest. All right, so all these pictures should have a triangle in them. All right, each of them should have a triangle, and you draw what's the name of each. So perpendicular bisector first. Can we draw a perpendicular bisector through a side with the correct markings? Hey, just a heads up. This is the only one out of the 4, perpendicular bisector. Only one out of the 4 that does not have to come from a vertex. Remember that. The other 3, angle, median, and altitude, all have to come from a vertex. Perpendicular bisector does not have to come from a vertex. So if I see something like this, that would be okay. It does not have to come from a vertex. But it should have what markings on here if it's a perpendicular bisector. What markings should be on one of the sides here? Bryson.
Like the right angle.
Yep. That tells me it's perpendicular. What about the bisector part?
Like hash marks on the bottom.
There you go. That tells me it's a perpendicular bisector. Without the hash marks, I'm not calling it anything, right? Because I can't call it an altitude because it doesn't come from a vertex. All right, you draw all three in. What's that point of intersection called? All three perpendicular bisectors intersect. Drew? Circumcenter. So that's the word I'm writing in here. And then you're writing what's so special about it, right? The special property. The circumcenter is, finish this off right. 1-4. Stephanie, what's so good about the circumcenter? Wherever I find the point is in the triangle, that's the circumcenter. It will be the same distance from what? All three? Yep. Okay. It's equidistant, the same distance from all three vertices, that point. From the vertices. And then you guys are taking it over from here now. Okay? Every example should have a triangle in it. And the last three here should come from a vertice when you draw it in. All right?